Senior .NET devs. Every time that you write virtual, you're making a promise that says, I expect you to change this. I've designed this method to be replaced. And if you're not making that promise intentionally, then you're lying to every developer who inherits your class. So let's talk about what virtual actually means, because sometimes a reminder is nice to have. I've been building .NET apps for a long time, and I've seen two types of developers when it comes to inheritance. The first type, the everything virtual developer. This person makes every method virtual, just in case, for flexibility, for testability, for reasons. And you know what you get? Untestable spaghetti. Because when everything can be overridden, you never know what's actually running. You're debugging and you think you're in the base class, but nope, you're 3 inheritance layers down because someone overrode it. So good luck to you. Every release is a breaking change because anything can be replaced and someone, somewhere, replaced it in a way that you didn't expect. And the second type is the seal everything paranoid. This person marks everything as sealed, and they avoid inheritance entirely. They write sealed classes everywhere. And you know what you get? Duplicate code everywhere. Forks instead of extensions. Teams that can't customize behavior without copying the entire class and modifying the source. Neither of these approaches are right. And here's what I've learned building frameworks that other developers actually inherit from. In my startup class, specific methods are virtual. Configure services, configure pre-auth middleware, configure post-auth middleware, configure web app. Those are not accidents. Each one is an explicit invitation. Your client project will need to add services. Your client project will likely need to add custom middleware before authentication and after. So come in, the door's open. But configure common, well, that method, that's the shared setup. It's not virtual. There's no invitation. That difference matters. So let's get specific. When you write virtual, you're making 4 different statements. One is, I expect this behavior to vary across implementations. Not might vary, I expect it to vary. Number 2 is, I've designed the base implementation to be either incomplete or reasonable default if it's meant to be changed. Number 3 is, I will maintain backward compatibility for anyone who overrides this. That means I won't change the signature. I won't change the expected behavior of calling base. I won't pull the rug out from underneath you. Number 4, I've thought about what happens when someone calls base.method versus when they skip it entirely. Both paths work. And if you can't say all 4 of those things, then the method is not ready to be virtual. So here's my litmus test. Before making any method virtual, ask yourself these 3 questions. First, can I document when and why someone would override this? If you can't write that documentation, you don't have an extension point, you have a maybe. And second, if someone overrides this and does not call base, will things break? If the answer is yes, you either need to make that explicit or reconsider the design. Maybe that logic shouldn't be in a virtual method at all. Third, am I prepared to never change this signature without a major version bump? Because once you make something virtual, it's a part of your public API. It's a contract. And changing it breaks people. So let me show you what good looks like. In my framework, here's a small portion of the base startup class. You can see I just simply have a virtual configure services, has a bunch of code that I've clipped out of here. But the whole point is these are things that all clients that will use my stuff will likely desire. But if they want to redo it all, they can totally call override and not call base. Or they can set my defaults, call override, call base. In fact, let me show that now with a client. So the client inherits from it. In this case, they want the defaults. So they call base, and then they call their specific client-specific services. So the base implementation is complete and it's useful. You can run the framework without overriding anything. The override adds, it doesn't replace in this case, it extends for the most part. And over here, the call to base configure services, it's expected, it's documented, it's part of the pattern. And the clients know exactly what they're extending. There's no mystery here. And if they don't want to extend that, they can override it without calling base. So let me show you an anti-pattern, something I see a lot of the times. So why is this virtual? Like, what's the extension point here? Well, maybe somebody wants to format names differently. Well, great. Make an iUser name formatter interface and inject it. Use composition. Virtual isn't for, I might want to change this someday. Virtual is for, I've designed this as an extension point with a specific purpose. If you can't name the purpose, don't use virtual. The mindset shift here is that you're always a framework designer. Even if you're writing internal code, even if you're the only one on the team, that code will be inherited by you in the future, by your teammates, by AI, by the contractor who joins in 6 months and has to figure out how to extend what you built. So think about methods in 4 categories. Category 1 is you must override. And that's abstract. You're saying, I can't do this. I don't have enough context. You must provide the implementation. And category 2 is may override. And that's virtual. You're saying, I've got a default that works for most cases. But if your context differs, then here's the door. Override it. And category 3 is won't override. There's no modifier. You're saying, this is how it works. This is the algorithm. Build on top of it. Don't replace it. Category 4, it's one that some people forget about, but it's the template method. And here's what that looks like. So you see what's happening here is the overall algorithm is locked. We validate, calculate, apply discounts, then finalize. That order doesn't change, right? But apply discounts, it's virtual. And this is where the client project can plug in their logic. Maybe have loyalty programs, maybe have coupon codes. In this case here, it's a seasonal order processor. And hey, if it's a holiday, we're gonna give a 10% discount. They don't get to skip validation. They don't get to mess with finalization. The invitation is specific, it's controlled, it's intentional. All right, let's get practical. What do you do with this? If you're the senior dev reviewing code, then when you see virtual, ask the author, what override scenarios did you design for? If they can't answer, then the virtual shouldn't be there. When you see a method that isn't virtual in a framework layer, ask, what extension point are we intentionally closing? Sometimes that is right, but sometimes it can be an oversight. Push for documentation. XML comments on a virtual method should explain 3 things: when to override, whether to call base, and what the contract is. If the documentation doesn't exist, then the design isn't really done. Now, if you're the architect designing frameworks, you can start without doing anything virtual because you can add virtual later. It's easy to make a method virtual in a future version, but removing virtual is a breaking change. So start closed and open doors when you have a reason. Prefer composition over inheritance when you can. Interfaces and dependency injection are often better than virtual methods. They're more explicit, they're easier to test, and they don't create the tight coupling. But when you do use virtual, be obvious about it. Name methods like on before process, apply custom rules, handle special case. Names that scream, override me. Names that tell future developers, this is your extension point. Virtual isn't just a keyword, it's an invitation with your signature on it. You're declaring, I hereby invite future developers to change this behavior, and I promise to maintain this contract. If you're not ready to sign that invitation, then the method shouldn't be virtual. It's just a method that will likely break things later. I'm Chad Carter, helping .NET teams ship production apps faster. You already know what you're doing, so now go and ship it. And hey, if this helped, you know the drill. Plus, you may want to go ahead and share this with a dev that you like. I'll see you in the next video.